well, applications of fractions and mixed numbers. But since we've already done operations, in this particular case, multiplication and division of fractions and mixed numbers, then as long as you can get the problem set up, then it usually turns out pretty good. So remember, when you're setting up fractions, at least if you set them up like this, or the amount and the total, then it usually generally tells us where to put values in fractions. However, since it's going to be giving us fractions to start out with, we may be able to look for some wording that really helps us out. Now, one of the key words we usually look for is of right here. Sorry, I put that in a different color. There we go. That looks pretty. We don't usually see a lot of this out of business right here, so I'm going to kind of scratch that one out. But of we do see, it's just knowing when to apply it, okay? Now, between the two, because really we're just looking at either multiplication or division. So with these word type problems, and I know I've said this before, is it may take several readings of the word problem, of the actual words that are given to us, before we understand which of the two operations are needed. Now, if you start thinking and you see that something is going to be divided or split up, or I don't know if there's, I'm trying to think if there's any other words than those two that would really help us know that we're looking at division. But no, that there's not really that. And they may not say, hey, we're specifically going to divide these up. Sometimes, well, I'm trying to think. Um, I don't think they'll use those two specific words. But if you start to realize that something is going to be split up, or that it is going to be divided up, then you'll know that, of course, you're going to be using division, all right? Outside of that, yeah, we're going to see this word of given to us in the word problems, and then we'll know that we're going to be using division. So I know that's not very specific, but it helps us get a start. So here's a problem. When making bread from scratch, the recipe calls for 2/3 cups of water. If you need to make a smaller portion of the recipe, how much water would you need in order to make only 1/6 of the recipe? Give your answer as a fraction reduced to lowest terms. Now, there's something that you'll need to understand on this one, and again, you may have to read it several times, especially when you're doing the homework, to really know what you're going to be doing on this one. But like if I saw this 1/6 of the recipe, then I know, look, we're going to take how much water was in the original recipe, okay? That's this 2/3 right here, okay? So I'm going to take my 2/3 cups of water, and I'm using blue because waters and blue seems to correlate right there. And this recipe says we're going to take 1/6 of the recipe. See, there's that key word that we said was in that last slide right there, of. Well, it's 1/6 of that, okay? So I'm going to take this 2/3. I probably should have placed it a little bit farther over, but we're going to take 1/6 of that 2/3, which means since it's of that 2/3, it's going to be multiplied like this. Okay, now this is a direct multiplication problem, and yes, you could cross simplify at this point, but I'm not going to. I choose to just multiply these straight across. All right, so in my numerator, I have 1 times 2, which is 2, and my new denominator, which is 6 times 3, which is 18. Now, if you can simplify these, you should. And this one, yeah, it told us that we should. So I'm going to reduce this to lowest terms. I know 2 and 18 are both divisible by 2. Because in the ones place values, we have even values. So 2 divided by 2, that's my new numerator, 1. My denominator, 18 divided by 2, is 9. Now, that was, I wouldn't say that was a lot of work, but it was some work, okay? Just understand that 1/9 is not the actual answer that we're looking for. Remember that these are word problems, so we need to label these. So to figure out what label we need, remember, and it may, again, this may come from rereading it, but it says how much water would you need in order to make 1/6 of the recipe. So we know it's 1/9 water, but is there a more specific measurement that can be used in this? Yeah, it was in cups of water that we were talking about. So not that I know what a ninth of a cup looks like, but it's a ninth cup of water that would be for this recipe if it was cut down from 2/3 into 1/6 of that. Okay. Now, keep in mind, when we did this in 2.5, which was applications of fractions, we would have set this up with two separate fractions. We would have said, okay, this is 2/3. That would be part of the recipe, and then the whole recipe would be one full recipe. So 2/3 of one, 2/3 over one would be the fraction. And then we would want to scale that up to a sixth of the recipe, which is the denominator, and then we'd have to figure out that numerator. I noticed when I did this with one of the other classes that it caused some confusion. So I'm actually going to skip that, although you could use it. So the reason I point that out is because the old method that we used in 2.5, it took some time. I would say it took a lot more analysis, but if we can just know that we're doing multiplication of fractions, especially where last time when we did multiplication of fractions, everyone seemed to feel pretty good about it, then things go pretty quick. So once again, if you can just set these up, then generally speaking, things go pretty quick. Especially since everyone feels pretty good about multiplication and division of fractions. So in that last example, we saw multiplication. Let's see about this one. If there are 12,440 students at Rocky Valley College, and 1/8 of the students take speech, how many students take speech at Rocky Valley College? Give your answer as a whole number. Okay. Now, do be careful, and I know we talked about this in 2.5. It is possible that a problem like this one could state as part of the problem, write your answer in lowest terms, which would indicate that the answer would be a fraction. But we know it's asking how many students take speech at Rocky Valley College. So yeah, we should be expecting a whole value on this one, okay? So here's what we got. We got this 12,440 students, right? So 12,440, that's in students right there. But then it says 1/8 of the students take speech. Now, there's one of those key words there, of. It's not out of, it's just of. 1/8 of those students take speech. Well, of the students, when it says of the students, it's talking about the students up here, the full amount of the students at the college. That's 12,440. So since it says of, that means I know I'm going to be multiplying that 12,440 by 1/8. Now, whether you put the 1/8 over here on the left of the 12,440 or to the right like I have it, doesn't matter. Because remember, order when we multiply values doesn't matter if it's fractions or whole numbers. It does not matter what the order is in. Okay. Now, if it was division, that would be crucial, but for multiplication, it does not matter. So on this one, what I want to do is I want to see this as a fraction, right? So I can multiply this fraction. And while you could do cross simplification on this one, I'm not going to on this one either. Okay, so I'm going to multiply my numerators straight across. 12,440 times 1, which is, well, 12,440. And then in the denominator, I have 1 times 8, which is 8. All right, now this is, when I get my answer out of this, I am going to label it in students, okay? But I don't want to label it yet because I got some more work to perform. Now, if you could say, well, I'm going to divide this by 2, and then you'd see that's divisible by 2, and then keep dividing by 2 if you wanted to. But I'm not going to do that, okay? What I'm going to do is I'm going to divide this by 8 directly, and while I don't know my multiplication tables of 8 all the way up to 12,440, when I put this in, I just want to see if it works, because remember, back here it said that the answer should be a whole number. So I'm kind of expecting that there's nothing remaining when we do this division, all right? So I'm going to take this and divide it by 8. Let's see what we get. And if I'm wrong, if there is a remainder, then I'll go back to my fraction here and keep dividing, all right? So 8 will go into, it won't go into 1, but it will go into 12. Let's see, what color should I use? Green. Let's use green. 8 goes into 12 once. 1 times 8 is 8. I'll subtract that and get 4. So I'll drop this 4 to make that 44. All right, so 8 will go into, that's 44. Sorry about my writing right there. 5 times. So 5 times 8 is 40. Yeah, I have to write that small because I didn't give myself enough space. But 4 minus 0 is 4. I'll drop this other 4 to make that 44. Well, 8 will go into another 44, another 5 times. 5 times 8 is 40. So I'll subtract that. How much? Oh, I'm running out of space there. So there's 4, and when I drop this 0, that'll work though. 8 will go into 40 exactly, just like I thought it would, 5 times. So that's going to give us nothing remaining. Uh, um, Now, a couple of different ways to look at this. So I know that this direct division right here, 12,440 divided by 8 is 1,555, okay? But if you didn't realize that, that's fine. You just continue to scale your fraction down, like I just divided both the numerator and denominator by 8, which then gives me this, well, it'd be 1,555 over 1. But we don't really need that divided by 1, so that's why this really just comes out. Since it was just the straight division right here, you could have gotten this one without having to do this scaling down like we did. So I showed it a little extra step here, but it's not necessary that you do, as long as you realize that you were dividing back here. So yeah, the final answer we know is 1,555. But let's go ahead and let's say that, yeah, we didn't notice that or know that it would be divisible by 8. And we said, okay, we need to divide both the 12,440 and the 8 by 2. We know they're both divisible by 2. Well, that would have given us a new fraction, which would have been 6,220, there, 220, yeah, all over 4, like this. All right, and then you would say, oh, well, I got a 0 in the 1's place value and a 4 in the place value, so I know that this can be further simplified by dividing that by 2, both of these by 2. So that would have given you 3,110 all over 2 right there. Now you can see we're getting really close to the answer that we got. But yeah, these now are further divisible by 2. And yes, I did run out of space here, so I apologize for writing small, but it is the same answer right there. 50,555 all over 1. And yeah, that'll produce the same this answer right here is the same one we got right here. Just don't write it as over 1 because we'll make that a phantom divide by 1. That's the identity property for division. Again, whether you did it with these 3 steps, like we showed you here, or whether you did it and you notice that this should be divided by 8. Again, I'm pointing out that I did not know that this would be a whole value right here. It just happened to turn out that way. So if you did this method, yeah, that's perfect. That's great. So again, here we have another word problem. The tank for a car holds 14 gallons. The gasoline gauge shows the tank is 1/8 full. How much gas is still in the tank? Give your answer as a whole number or as a mixed fraction reduced to lowest terms. Now, I'll point this out. I'm not going to actually perform the operation. But let's say that you perform the wrong operation on this one. If you do, you're going to get a very, very, very clearly incorrect answer as long as you've read this and understood it, okay? So let's look at what the correct operation is to perform between the 14 and 1/8 right here. Now it's 14 gallons. That's the size of the full tank on that, okay? It's 14 gallons of gas. Now it says it's an eighth full, so another way to word that, and I know it doesn't say this explicitly in the problem, but that's like saying that it's an eighth of the tank is, well, it's just an eighth of the tank full. It's not a full tank; it's just an eighth of the tank full. Okay, and if you think about it in that terms, and I didn't, I kind of forced the word "of" into that, but you know, if you start thinking about it in those terms, then you see that the word "of" is in there, which means that, yeah, we're going to be multiplying this 14 by, well, 1/8 right there. Okay. Um, so I'm going to finish this, but let's say that, after I do finish it, I'm gonna point out that if you said, well, it was 14 divided by 1/8, I'll point out why that's a very, very, and it should be very clearly why it would be incorrect. Okay. Now that 14, I'm going to make it over 1, so I can do some fraction multiplication here. So that's in the numerator is 14 times 1, which is 14. And yeah, some of you would have cross simplified at that point. That's fine too. But 1 times 8 is 8. I'm choosing to simplify at the end here. It seemed like it was the simplification of choice to do it at the end. That's okay. 14 and 8 are both divisible by 2. So let's go ahead and simplify this. 14 divided by 2 is 7, and 8 divided by 2 is 4. So give your answer as a whole number or as a mixed fraction. Oh, okay. Well, we do want a mixed fraction on this one, or a mixed number. So 7/4 as an improper fraction will not work. So that means we're going to have to go to the long division on this one. But do remember that the denominator will stay the same. So where it was at 7/4 for the mixed number, the denominator will still stay in fourths. Recall also that your quotient will be the whole number, and then whatever's remaining will be your numerator right here. So let's go ahead and do 7 divided by 4. It's not a hard division. It shouldn't be. So 4 will go into 7 once. 1 times 4 is 4, so let's subtract that out, and that gives us a remainder of 3. So remember the quotient, that's the whole number, that's the big one, big value in the whole number, and then the remainder of 3, that's the numerator right there. So as a mixed number, we get 1 3/4. But don't forget to label this, okay, because that's 3/4. It says how much gas is still in the tank, and we were talking about gas in gallons, so yeah, that's in gallons as well. 1 3/4 gallons of gas is still in the tank. So that would be the answer right there. It's a pretty good answer. It's pretty good. That's an S. There we go. Now, again, let's say that you made the assumption, which we now know is incorrect, but let's say that you made the assumption that it was 14. I'll try to do this small so we don't get it mixed up. But let's say that you did 14 divided by 1/8. Now, without showing the math, here's what you get on this one: 80, 112. Now, if you got that 112 right there, you would notice that that would be in gallons, and that's only an eighth full of 14 gallons. Okay. Now, again, this comes from reading the problem and understanding it. If you did this incorrectly and you said, well, 14 divided by 1/8, and you got 112 after all the 112 after all the math, that's more gallons than the tank holds, and it can't be eighth full and then be more than the gallons that the full tank is. So if you do by chance perform the wrong operation, it should become very clear that you're looking at the incorrect answer. Just in the context of the problem. It is estimated that each guest at a party will eat 2/3 ounces of chocolate. That can be ounces. How many guests can be served with 6? Again, yeah, sorry about that. Should be ounces of chocolate. Okay, now again, let's think about this. We're going to take 6 ounces and we're going to start. Well, what are we going to do with that 6 ounces? We're going to take it and split it up amongst people at the party. So since we are splitting up 6 ounces of chocolate, I'll put this down in the note here. So we are splitting 6 ounces of chocolate. That's a hard word to type. And now again, I'm pointing this out because we're splitting it up, and that's the key word right here, because splitting it up indicates that we're going to be using division. Let me see if I can make that a little bigger. Splitting it up, I could have used the word dividing it up, but I thought that was a little too direct. So we're splitting up. What are we splitting up? 6 ounces of chocolate. Boom. Now that means we're starting with 6 ounces. Remember, that's always going to be your dividend, or the first number in the division problem. So where we're starting with 6 ounces, we're going to divide it up. Start with 6 divided by, well, how much does each guest get? That's just 2/3 right here. So we're going to divide that by, oh, if I can write this correct, 2/3. There we go. 6 divided by 2/3. Now this is good. This is a good start to set it up, because we feel pretty good about that. And since we do have it started setting up, then we're going to keep that dividend the same. But again, we don't actually divide. We're going to be multiplying. It's just if I do, then I need to also flip that fraction. So the divisor fraction there, 2/3. So instead of it being 2 in the numerator, it'll be 2 in the denominator. Instead of 3 in the denominator, it'll be 3 in the numerator. That's all. And yes, I will show that as 6/1, so we can do some multiplication there. Fraction multiplication, right? So I got 6 times 3 in the numerator, which is 18, all over 1 times 2 in the denominator, which is just 2. Now that's 18 divided by 2, but that's a scalable fraction. I know that I can just divide those both by 2. That's not hard. 18 divided by 2 is 9. 2 divided by 2 is 1. Now, just like we talked before in the other problem, I don't want to show it as 9/1. I just want 9 in this case. And last thing I need here is a label. And what was the question? It was how many guests can be served. I'll keep there. How many guests can be served? So that means that actually we're looking for 9, and that label would be, well, guests. There we go. So 9 guests will get 2/3 ounces of chocolate each with the 6 ounces of chocolate that we have. 1/2 of a birthday cake was left over from a party. The next day it is shared. Well, there's a word. It's not one of the key words, but if I were to look at the word shared, I would think, oh, it's being split. It's being divided, right, among 6 people. How big a piece of the original cake did the person get? So we are looking for the size compared to the original cake, but we're looking at how much they're getting of half the cake, which was half of the original cake. So remember, since we know we're dividing now because we're splitting up that half cake, um, since it's being split, it's being divided, so we're using division. But remember that the dividend, the number that goes to the left of the division sign, is how much you start with. And in this case, we're starting with half of birthday cake. So I'm going to put that half in front here as 1/2. Well, that 1/2 is going to be divided amongst 6 people. So I am dividing it amongst 6 people here. And so it reads 1/2 divided by 6. And hopefully that makes sense, right? We're taking half the birthday cake, we're dividing it among 6 people. Half divided by 6. So again, I think that's where a lot of the heavy lifting occurs because we already, well, as far as I know, it seems like everyone feels pretty comfortable dividing fractions because then we change it to multiplication, which is nice. But if we can just get this set up, then we're well on our way to finishing this problem. So 1/2 divided by 6, yes, we do not divide fractions or with fractions. So that 1/2 dividend will stay the same, but I'm going to change that operation from division into multiplication. Yeah, I may have to look at 6 as 6/1 so that I can flip it or reciprocate it. So now the 6 will be in the denominator and the 1 in the numerator, so now it's 1/6. And this is pretty direct right here. Well, let's go and multiply these. So I'll just do straight multiplication. I don't see any cross simplification on this one either. So my numerator is 1 times 1 is 1, and my denominator is 2 times 6 is 12. So how big of a piece of the original cake did each person get? Well, that's the value we got right there. Each person got 1/12 of the cake, 1/12 of the cake. I guess I'll just put that 1/12 of the cake. I don't know. I feel like it's kind of redundant because remember the denominator tells us how big the size pieces are. So I don't want to put like 1/12 piece or 1/12 size, but I guess that's kind of what I put. So 1/12 of the cake is how much each person got. And you can be more specific about that if you'd like, but I'm going to put it like that. Okay. Now again, I'm gonna point this out. Let's say that you had maybe you had switched these two and you said 6 divided by 1/2. Okay. If you did that, you'd get 12. Now we know that it's 12th size of pieces, 1/12 size pieces, but it's not like you're getting 12 pieces, okay? So if you had switched those two, then you would have gotten something like that. Or let's say that you multiply it instead. 1/2 times 3, 1/2 times 6, and again, not showing the math, that'd be 3. It'd be like saying, well, each person got 3 pieces. It doesn't really tell us the size of the piece, which is why we need this in this fractional size. So again, this comes with some analysis. It comes from stopping and thinking about what it is that it's asking, and the values that are given. Okay, I mean, does it make sense for each person to get 3 pieces? Well, I guess, I mean, 3 pieces perhaps, but it doesn't really tell us the size. So, and that's really what it was asking. How big of a piece is each person getting? Not how many pieces. That's different. Donna is going to swim 25 laps. She has completed 20 laps. What fraction of laps has she completed? And yeah, we're going to need to simplify these ones once we see our answers. And so it's saying it wants a fraction, right? Remember from that first slide, it said that partial amounts or amounts, uh, part amounts are the numerators, and then the whole amounts are the denominators. Well, we know from this one that she's going to swim 25 laps. That's the whole amount of laps that she's going to do. That's the total amount of laps she's going to do, 25 laps. This one is specifically asking how many she completed, and it told us up here she completed 20 laps. So right now she's completed 20 of the 25 laps. And yeah, that can be simplified. Both of these are divisible by 5 because there's a 0 and 5 in the ones place value. So let's start with that. See where we get. 20 divided by 5 is 4. 25 divided by 5 is 5. So I got 4/5. That cannot be further simplified. Um, I'm trying to think of the label on this one because it is a word problem. She completed 4/5 of the laps. That sounds good. And again, this is completed. Now I'm going to proceed. Some of you would proceed with the 4/5 and you'd have that simplified answer right away. I'm going to assume that we didn't see that. Let's say that we didn't, although you can. And so I would be looking again at a new fraction. Still 25 laps though, okay? But this one, it wants to know what fraction of her swim remains. So if she's looking at 25 laps, right now she's performed, in fact I should do this over here. She's looking at 25 laps. Right now she's performed 20 of the laps. So that means she has 5 laps remaining. So right now she has 5/25 of her swim remaining, but this can be simplified also. So the 5 and 25 are both divisible by 5 because of the 5 and the ones place values. 5 divided by 5 is 1. 25 divided by 5 is 5. So, I'll just put remains. The laps, it's not really laps. I guess it's of the swim. Remains. That sounds pretty good. Now, so I got this from subtracting the 5. And remember, this is crucial that we understand what the question was asking for. What fraction of the swim remains? That's the full 1/5 right there that we need. It's not asking how many laps. That would be it would be worded differently, of course, but that would change the answer instead of from a fraction to then a whole value, which we would have seen as 5 right there. Now, the other way you could have done that is you could have said, well, if she has 4 of the fifths that she's completed, like we found in red there, then you could have taken 5 minus 4 rather to see that you'd have had 1 of the fifths remaining right there. Either way, again, just remember that the full answer right there is the fractional part because it wanted the answer in fractions. A room is 11 1/4 feet wide. That's a mixed number, and 8 feet long. Find the area of the room. So just to go back, remember that to find the area, what we're going to do is we're going to take the length and we're going to multiply it by the width. And that's all we're looking at in this one is length and width. So this is a rectangular room, and this is not proportional, not that it has to be, but it says that it's 11 1/4 feet wide. So there's my width right there, 11 1/4 feet, and then the length, 8 feet. Okay, so I know I've drawn that modeling of it, but it's not really required that you do, of course. So if you want to find the area, we're going to take the length, which we know is 8, and we're going to multiply it by the width, which is 11 1/4. Now, what we know already is that we don't usually multiply these straight across, although you could. That's a different method for a different time, though. So we need to change any mixed numbers into improper fractions, okay? And we do that with this cycle method stuff. So instead of it being 11 1/4, remember it's cycle method. So 11 times 4, that's 44. And then add the 1 there to make that 45. Now that's a new fraction, by the way. It's still going to be 8 multiplied by that. But the numerator is 45, and the denominator stays the same at 4. Now there's multiplication. So that 8 also, I'm going to change that into 8/1. Now, I don't know. I haven't shown cross simplification today, so I kind of feel like I should. And I see the 8 and 4 right there, okay? So the 8 and 4, I know I can simplify those. 8 is divisible by 2. Well, actually, it's divisible by 4, isn't it? So I can divide the 4 also by 4. Okay? So let's go back. I needed the space on that one, but there we go. So my new fraction for multiplication after cross simplification here, 8 divided by 4. Let's see, I got my two fractions. Sorry, 8 divided by 4 is 2, and then 4 divided by 4 is 1. Well, we still got the 45 in the numerator there, and then the orange 1. Still need more space. Sorry about that. So, some multiplication now. Let's see, what color? I'll use red. 2 times 45. Let's see what we get. 45 times 2. 2 times 5 is 10. Carry the 1. 2 times 4 is 8, but plus the 1 is 90. So that's a numerator of 90. All over 1 times 1 is 1. And remember, if you got divided by 1, just make it a phantom 1 at that point. So I do have 90, but I need my label now. It's area, and it was feet times feet, so that would mean that we're dealing in square feet on this one. Square feet, remember, and this is good for now, but remember on the assignment, it may just have that label a little different. It may show it as 90 feet squared. But remember, that's still the same label. It's just showing it in a different way, that's all. So remember that area, and this is a rectangular room. I won't worry about drawing the model for this one because it didn't really help us on that last one. Though if you found that it did, then do use it. But yeah, we're looking at 15 3/4. That's my length. Put in purple, I guess. 15 3/4 by, so that'd be multiplied because we're doing area by this, well, 12 and a half. And yeah, that's doable right there. Just remember that as of now, while we're multiplying mixed numbers, we're going to want to change these into improper fractions. So I do that with cycle method, right? So I'd say, hey, look at my, what happened there? 15 3/4. So that's first is multiplication. So the whole number times the denominator, 15 times 4. And I'll do the quick math on that, 60. And then we add the numerator there, 3. And yeah, that gives us 63. So now, instead of it being 15 3/4, what I have from the purple fraction, again, the denominator stays the same as 4, but I found a new numerator at 63. There, all right. And this is all being multiplied by a new fraction from the 12 and 1/2. So let's go there. Let's do that 12 and 1/2 with the cycle method again. So that'd be 12 times 2. Let's go and do that math. 12 times 2 is 24. And then we would have to add the 1 numerator there. So let's go and do that. Plus 1. And I get 25 from that part right there. Okay, so that's my new numerator from the 12 and 1/2. Once again, the denominator won't change, but the numerator now is 25. The denominator was 2 from the fractional part of that mixed number, so we'll keep it as 2. I don't see that we can do any cross simplification. I do believe that the answer we'll want the answer as a mixed number. Yeah, for a problem like this one, I assume they'd want the answer as a mixed number. We'll show both, of course, because once we do the multiplication on this one, it will be an improper fraction. So let's go ahead and do that one. Some good multiplication for us. We haven't seen this in a little while. So 63 times 25. Let's go and do that first. I guess I'll use orange. Multiplication, right? So 5 times 3 is 15. Carry the 1. 5 times 6 is 30, but plus the 1 is 31. Now I'm in the tens place with the 2. 2 times 3 is 6. 2 times 6 is 12. So when we add those together, we get 5. 6 plus 1 is 7. 3 plus 2 is 5, and then the 1 there. So my new numerator is 1,575. All over, let's do the denominators. That one's not too bad. 4 times 2 is 8. That's good stuff. All right, so I have 1,575 divided by 8. But like I said, we're going to change this improper fraction. It cannot be simplified, by the way. And so if by chance the assignment wanted this as a improper fraction, you'd just change, you'd label this in square feet, okay? But I'm assuming that we're going to take this a step further and change this into an mixed number. So 1,575, and we'll go and divide this by 8. And whatever we get, the quotient will be the whole number in the mixed number, and the remainder is the numerator of the mixed number. So in the mixed number, by the way, we know that the denominator will stay the same. So where it is already an 8, I will keep it as an 8. Let's go and do that long division right there. 8 will not go into 1, but it will go into 15 one time. 1 times 8 is 8. Subtract and get 7. 15 minus 8 is 7. 8 won't go into 7, but if I drop this 7 to make it 77, 8 will go into 77 9 times. 9 times 8, 72. When I subtract, I'll drop this 5. 7 minus 2 is 5 there as well. Dropping the other 5 makes that 55. And 8 will go into 55. Let's see, not 7 times, 6 times. There we go. 6 times 8 is 48. I'll need a little extra space there. Probably should have wrote that smaller. But this will be my remainder because borrow the 1 there from the 5. 15 minus 8, which is 7. So I see the remainder is 7. That's the numerator in the fraction part of the mixed number. And then the quotient, 196, is the whole number there. I just need a label on that one. Let's see if I can fit this in there. This is in, I'll put it in feet squared. That's a little bit narrower. Is that a word, narrower? But yeah, that's the answer right there for this one. 196 and 7/8 square feet. The Jones family recently sold their home for $185,200, but 3/50 of this amount goes to the real estate company that helped them sell the house. How much money did the Jones family pay the real estate company? Good question. So that's pretty common. This, by the way, is 6%, which is, as far as I know, is pretty common. But there's our key word there, of. Boom. Okay, which means that we're dealing with multiplication. Multiplication of what? Well, it's 3/50. If I can give myself some space here. It's 3/50 of, multiplied, $185,200. So yeah, we are looking at multiplication on this one. And again, if just by chance, if you divided it, you'd see pretty quickly that that's not very convenient, nor is it, well, I mean, it's doable. It's just, it wouldn't be convenient. It wouldn't make any sense. That number would be very, 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 very small. It'd be past the penny. It'd be like a fraction of a penny, which, again, shouldn't make sense. Or even if you switch these around, then it still wouldn't make sense. The number would be too big then. So just the way that we have it set up is going to work. And let's see. Let's go and do this multiplication right here. I got 185,200 times 3. Let's see what we get. 3 times 0 is 0. 3 times 0 is 0. 3 times 2 is 6. 3 times 5 is 15, so we'll carry the 1. 3 times 8 is 24, but plus 1 makes that 25, so we'll carry the 2. 3 times 1 is 3, but plus 2 is 5. There we go. So that new numerator from the multiplication is 555,600. All over. The denominator is multiplied. Anything times 1 is itself, so that's 50. So we're going to go into division on this one. We're going to use some long division on this because we got a big number in the numerator. And no, I don't have my 50 multiplication tables memorized that high. Same with 5, by the way, which is actually what we're going to work with. Remember, going back to division of numbers from, what was that, module 2 maybe? If you have zeros at the end of numbers like we do here, if you find matches in numerators and denominators, you just cross those out. Those are really phantom ones. And really, I mean, instead of just crossing it out, we really just kind of erase it. So now it makes the number smaller, 55,560 divided by 5. And I think that's a little bit more doable for us, having got rid of the 0. But you can work with the 50 if you'd like. You're going to get the same answer. So let's see, what do we get then? 55,560. And we're going to divide this by 5 right there. Let's see what we get. 5 goes into 5 once, so subtract that 5. That's going to zero that out. Drop this 5. 5 goes in that 5 once, so subtract 5 there. Drop this 5. 5 goes into that 5 once. That's convenient at least. So subtract another 5. I need a little bit more space. That's going to zero that out, drop the 6. 5 goes into 6 once, but yeah, I'll subtract the 5 and make that a 1. Drop the 0 to make that 10. 5 goes into 10 twice. That'll go into that evenly, so that's going to subtract the 10 right there. So you have 0 remaining, which is really good, which means that that would be our actual answer right there, 11,112. You can put a comma there if you'd like. And yes, this is asking how much money. Money for us, yeah, we use the dollar symbol. And that's it. A contractor has 155 kilograms of concrete. He needs to make bricks using the concrete. I don't know why that's there. Each brick requires 4 3/7 kilograms of concrete. How many bricks can be made from the concrete he has? You know, this I think this is a good opportunity, especially since this is kind of a short lesson today. But let's take 1 minute. Take 1 minute. See if you can do this one, and then as we find the answer on this one, you can check your work against what we do. Okay, but take 1 minute, try this one out, then we'll go over it. Now, if you're still working, keep working. I would recommend, and then then join with us, and then see where you're at if you've done it correct. Okay, and you may not use the same exact method that I do, but you should get the same answer either way. All right. So on this one, we'll notice a couple things on this, and that's we got this 155 kilograms of concrete. It's going to be split into bricks that are 4 3/7 kilograms, and that's how much concrete is needed to make a brick, apparently. So we know we're splitting up that 155 kilograms, right, into equal 4 3/7 size pieces. So yeah, we're going to need to divide on this one. That's important to know that we are using division on this one, okay? Well, what are we dividing? Well, we're dividing the 155 kilograms of concrete. So that's how much we're going to start with, right? So yeah, we need to acknowledge that we're taking 155 there, and then we're going to divide it, okay? Sorry, I had to make that a little small to make that fit. Sorry about that. Well, how is it being divided? It's being divided into 4 3/7 size kilograms of concrete. 4 3/7 right there. So we have 155 divided by 4 3/7. This will tell us how many bricks can be made from that concrete. And we'll see if there's any remainder. I don't know if there is or not yet. But I'm going to want to change that 4 3/7 into a improper fraction. And yeah, some of you could change it into an improper fraction and simultaneously change the operation. I'm not going to do that though. I'm going to do it in 2 separate steps. Okay? So 4 3/7, let's go ahead and use some cycle method on that to change it into an improper fraction. So I got 4 times 7 first, which is 28. And then I'll add the 3 numerator to get 31 right there. So that fraction has a new numerator. Yeah, we're not going to change the 155 dividend, but yeah, it's still going to be divided by. But yeah, that numerator is 31, and the denominator stays the same at 7. Right? So this sets up the division problem, but we don't want to divide fractions. We'd rather multiply them. So let's go ahead and do that. And show that as 155 over 1 now that we know that we're multiplying. Changing the operation now to multiplication will flip that fraction. Instead of 31 over 7, it is now 7 over 31. So and this may take a little bit too, but some of you'd say, well, I can cross simplify there. Not a lot of people would notice that because we're looking at a multiple of 31, which is true, and 31 is prime. But not a lot of people are going to notice that, so I'm actually going to go into fraction multiplication, all right? So I'm going to multiply my numerators and denominators. So what do I get? 155 times 7. Let's see. 7 times 5 is 35. Carry the 3. 7 times 5 is 35, but add the 3 is 38, so I'll carry that 3. 7 times 1 is 10. 7 times 1 is 7, but add the 3 is 10. There we go. So my new numerator is 1,085, and 1 times 3 in the denominator is 31. Now, like I said, 155 is a multiple of 31, and you don't have to know that. But whether you did or not, you should be looking to divide it in this case just to see if it will come out correct. It's not required that you would know that 1085 is a multiple of 31, although we'll find out that it is. So we're going to take 1085, I almost did a 3 right there, and we'll divide it by 31. Let's see what we get. Now, to do this, let's go ahead and see what the multiples of 31 are. So we'll go and make our list here. Yeah, sorry about that. Copying sometimes is hard for me. Well, I'll try to I'll try to dial that in the future. 31 though, yeah, 31. It's our first multiple. I'll put a check next to the multiples, and the next multiple, just gonna add 31 to that. Then be 62, which is the next multiple. Add another 31. You get 93. Looks like. And then add another 31. And yeah, it's not required that you do this fast, but I do hope that it helps. Add another 31. Let's see if this is enough. 155. There's that 155. See that? That's one of the multiples. So let's see if this is enough. I don't know that it will be, but we'll find out. Okay. So 31 will not go into 1. It will not go into 10, but it will go in 108. That's the third multiple right there, that 93. So 3 times 31 is 1. Oh, sorry, 93 rather. So I'll subtract that out. 8 minus 3 is 5. 10 minus 9 is 1. So let's drop this 5 here to make that 155. Boom, there it is. That's that 155 there at the bottom. That's the fifth multiple. 5 times 31 is 155, yeah. So when I subtract this, we see that the remainder is 0. So after dividing this, we don't even need the mixed number on this one. It's just 35. Now, remember that the answer isn't just 35. We do need to label this. And it was asking how many bricks can be made. That's 35 bricks. Sorry, again, I wrote that kind of small in the end just because I ran out of space. I look at a problem like this and I do see, I would say that's a lot of work. I mean, it's not a ton of work, but it's a lot. I'm not saying that it's hard though, right? I mean, we've already changed mixed numbers into improper fractions. We've already divided fractions. I mean, you know, the multiplication was bigger, the division was bigger, but is it more difficult? I don't think that it is because we've already learned all that stuff.